This question says, if log y base 81 equals to 3 over 4, find y. Option A, 27, 9, 63, 162. So how do you solve this question? It is very, very simple. All you just need to do is, when you have log a base x equal to y, and they ask you to find y, so what you do is, this base x raised to the power of y will give you a. What do I mean? So if I want to remove this log, all I have to say is x raised to power y equal to a, and I will be able to get the answer. So that law is what we are going to use here. And how do we do that? All you need to do is log y base 81 equals to 3 over 4. So what do? 81 raised to power of this will give us this. And that's going to lead us to law of indices. Alright, so you are going to rewrite it as 81. That will be 81 raised to power 3 over 4 is equal to y. According to the law of indices, when you have a value and it has a power, which is a fraction, the numerator of the power, the numerator will form a power, while the denominator will form a root. What does that mean? So this 4 will form 4th root of 81, all raised to power, the numerator power 3, equal to y. Now what's the 4th root of 81? It means what will I multiply by itself 4 times? That will give me 81, that is 3. 3 by 3 is 9, times 3 is 27, by 3, 81. So that is 3. So that's going to be 3 raised to power of 3 equal to y. Therefore, my y is going to be 3 raised to power 3 means 3 times 3, 9 times 3, 27. So y is 27. Do we have that in the option? The answer is 27. And that is how to solve this simple question. Talking about the rules of sort. The first thing you need to know is what are numbers that you can call sorts. When a number has a square root, all right? For example, if I have root 50 and they ask you to write this, it's already written in sort form because it has a square root. So I can break this down into root 25 times 2. You know, 25 times 2 is still 50. Now, as you are breaking it down to the factors of 50, these are factors of 50, but make sure at least one of the factors is a perfect square. 25 is a perfect square. So the square root of 25 would be 5. All right, root 2, because I cannot find the square root of 2. So that would be the answer. So let's see what the rule says. Number 1, if you have root of a times root of b, it's going to be root ab. Number 2, if I have root a divided by b, it's going to be equals to root a over root b. Number 3, if I have a root x multiplied by b root y, it's going to give me ab root xy. So the two values outside the square root we multiply, those within we multiply. Number 4, if I have a root x plus b root x, can you see both of them under the square root are the same? So I will just say a plus b root x, right? If I have a root x squared, a root x squared, this square root will cancel this square. So the square root will cancel the square, and the answer is going to be ax. Now, those are the rules of sort. Now let's see some examples from what we have done so far. Let's see some examples. Number 1, if I have root 2 multiplied by root 3, it's going to give me root 6. If I have root 9 divided by root 3, that will be the same thing as root 9 over 3, and that's going to be root 3. Right. If I have 2 root 2 plus 3 root 2, that means I have 2 pieces of root 2 added to 3 pieces of root 2. It's going to give me 5 pieces of root 2. All right. If I have 3 root 2 multiplied by 5 root 3. The two values outside the square root we multiply, that will be 15 root. Then the two values we multiply root 6. That is the answer. I hope that is clear right now. In solving this question, I'll show you how to answer questions on SOD in your forthcoming exam. Now the question says simplify 5 plus root 7 divided by 3 minus root 7. So what they are simply asking you to do here is to rationalize the denominator. In mathematics, you are not allowed to have square roots in the denominator. So you have to remove the square root. So what can we do to remove the square root? You have to rationalize the denominator. So how do we do that? Come with me. So you're going to have 5 plus root 7 over 3 minus root 7. And then you multiply both the numerator and denominator by this value, but you change the sign from minus to plus. If it is plus that was here, you change to minus. What do I mean? Multiply by 3 plus root 7 over 3 plus root 7. So we are going to multiply these two values together. So let's try to do that. So the first thing you do, 5 into bracket 3 plus root 7, all right? Then plus root 7 into 3 plus root 7, all right, all over. You do the same. These three we multiply both, minus root 7 multiplies both. That's 3 into bracket 3 plus root 7, then minus root 7 into bracket 3 plus root 7. So we open this bracket. 5 times 3, 15 plus 5 root 7 plus 3 root 7 plus root 49, that is root 7 times root 7, all divided by 3 times 3 is 9 plus 3 root 7 minus 3 root 7, minus times plus is minus root 49. And that's going to be what? That's going to give us 15 plus 5 root 7 plus 3 root 7 will be 8 pieces of root 7. That means you have 5 pieces of root 7, you have 3 pieces of root 7 altogether, pieces of root 7, then plus root 49 is 7, all divided by 9. So plus 3 root 7 minus 3 root 7, you are having 3 pieces of root 7, you are weighing 3 pieces of root 7, so you cancel each other and your depth is cancelled, alright? So the answer is going to be minus root 49, which is minus 7. So in total, we are going to have 15. 15 plus 7 is 22 plus 8 root 7 all over 9 minus 7 is 2. 22 plus 8 root 7 divided by 2. So this 2 is going to divide this value and this value. Because if I split this, it will be 22 over 2 plus 8 root 7 over 2. So if I divide it, 2 we divide 22, it will be 11 plus 2 divides 8, that's 4 root 7. So the answer will be 11 plus 4 root 7. So how do you write in standard form? The first thing you need to know is that a number is said to be in standard form when it is written in this manner. A times 10 raised to the power x. Alright, where your A is a number from 1 to 9.9. A positive value or integer from 1 to 9.9. And your x is positive or negative whole number. So the power is a positive or negative whole number. So let me give you an example. If I have 2 times 10 raised to the power 5, these are examples of numbers in standard form. Let me give you another example. 3.6 times 10 raised to the power minus 2. This is a number in standard form. 3.6 is a number between 1 and 9.9. 2 times 10 raised to the power 5. 3 is a number between 1 and 9.9. So let's see, how do we convert from decimals to standard form? So if I have, for example, convert 0.0036 to standard form, convert to standard form. So how do we answer the question? So there are 4 basic rules I'm going to quickly show you. that you're going to use to answer questions or convert to standard form. What are the rules? Number one is locate the first decimal point. Locate the first decimal point. Number two, introduce a second decimal point. Where do I introduce a second decimal point? After the first, or after the first significant figure. Then the next rule, count from the first to the second decimal point. Then the last one is if counting forward, it will be minus. If counting forward, it is minus. Then if counting backward, plus. So there's an acronym for this. I have given it BPFM. What is the meaning of BPFM? So BPFM means when you are counting backward is plus, when you are counting forward is minus. All right? So backward is plus, forward is minus. Now let's apply these 4 rules to solve this question. Convert this to standard form. So the first thing I need to do is to locate the first decimal point. What's the first decimal point here? This is the first decimal point. Now the next is to introduce a second decimal point after the first significant figure. What is the first significant figure here? All these zeros are non-significant. All right, so the first significant figure there is 3. So I am going to introduce a new decimal after the 3. So that's going to be 0.0036 point. So that is my second decimal that I have introduced there, right? Then the next thing says count from the first, this is the first to the second decimal. So I'm going to do 1, 2, 3. 3. So take note of that 3. And then the last one says if counting forward is minus. So because I counted forward, it's now going to be this 3.6 times 10 raised to power, because I counted forward 3 times. 1, 2, 3 to be minus 3. 3.6 times 10 raised to power minus 3. So I have succeeded in converting this from decimal to standard form. That is the simple way to convert from decimal to standard form. So I hope you understand that. Out of 3 students in the test is 5, 6, and 7. Find the standard deviation of their scores. What's the formula for standard deviation? So standard deviation. Formula for standard deviation is S is equal to square root of variance. And what's the square root of variance? Summation fx minus mean squared over summation f. Summation f into x minus mean squared over summation f. That is the formula for standard deviation. So my standard deviation S is given as this. So the variance is this formula inside here. Well, by the time I put a square root on it, that is the standard deviation. The question, the scores of 3 students in the test. The scores are 5, 6, 7. Find the standard deviation of the score. So to find the standard deviation of the score, 5, 6, 7. This is my x. The frequency is 1, 1, 1. All right. So my fx is what? 5 times 1, 5, 6 times 1, 6, 7 times 1, 7. So the summation, so my mean is going to be what? Summation fx over summation f. That means summation of this, 6 plus 7, that is 13, 18. So mean is 18 divided by 3 over summation f, 3. That's going to be 6. So my mean deviation
x minus mean. That means this 5 minus 6 is minus 1. 6 minus 6, 0. 7 minus 6, 1. Alright, then we go to the square of it. Minus 1 squared, 1. 0, 1. So then f of x minus mean squared. This mean squared. So f, we are multiplying frequency by this, give us 1. 0, 1 times 1, 1. So summation of this will give us this up. That is 2. So our standard deviation is going to be summation f of x minus mean squared all over summation f. That's going to be square root of everything up is 2 over summation f is what? 3. So the standard deviation is square root of 2 over 3. Do we have that in the option? Yes, that is option C. So the answer to number 1 is C. Number 2 says calculate the standard deviation of the following. So what are the parameters or numbers? 7, 8, 9, 10, 11, 12, 13. We do the same. X, frequency. You have 7, 8, 9, 10, 11, 12, 13. Frequency 1, 1, 1, 1, 1, 1, 1. Then the fx will be what? 7, 8, 9, 10, 11, 12, 13. Our mean will be summation fx over summation f, which is equal to summation of this. If you add all of this together, this 15, this 24, 34, 45, 57, 70. 1, 2, 3, 4. Yes, 5, 6, 7. Yes, that's 70. So summation of f is 70 over what summation of f? 1, 2, 3, 4, 5, 6, 7 over 7. That's 10. So the mean is 10. So what will be mean deviation? Then mean deviation squared. So the mean deviation will be x minus, so this minus 10, minus 3, 8 minus 10, minus 2, minus 1, 0, 1, 2, 3. We will square it. 9, 4, 1, 0, 1, 4, 9. Alright? Then we look for f of it. F of this value. That's frequency times this. 9, 4, 1, because they are 1, 1, 0, 1, 4, 9. So let's look for the formation. 13, 14, 15, 19, 28. 28. So our standard deviation will be summation f x minus mean squared over summation f. And that's going to be what? Square root of 28 all over summation f is 7. 20 over 7 is 4. So square root of 4 is 2. Let's find the mean deviation of the set of numbers. So the x is what? 4, 5, 9. Frequency 1, 1, 1. fx is what? 4, 5, 9. Summation of fx is 14, 18. Summation f is 3. So my mean is going to be summation fx over summation f. That's going to be what? 18 over 3. That's going to be 6. So when they say we should find deviation from mean, so the deviation from mean is going to be x minus mean. The summation of it, that's going to be the answer. So what is x minus mean? This is my x. 4 minus 6 is minus 2. 5 minus 6 minus 1. 9 minus 6, 3. Right? So the summation is what? Minus 2 minus 1 is minus 3 plus 3. The answer is 0. So the answer is 0, option A. So the answer to this question, the mean deviation is 0. That is the addition of what you have here. Number 4. Number 4 says you have a table x 1, 2, 3, 4, 5. They were giving frequency to be 2, 1, 2, 1, 2. The question says, find the variance of the frequency distribution below. Find the variance. How do we find the variance? X, F, Fx, x minus mean, then x minus mean squared. Then we look for f of x minus mean squared. Then we look for the summation. So this is 1, 2, 3, 4, 5. The frequency is 2, 1, 2, 1, 2. The fx will be 2, 2, 6, 4, 10. Then we need to find our mean. The mean will be what? Summation fx over summation f. Summation of fx is 24. Summation of f is 3, 6, 7, 8. So that's 24 over 8. That's equal to 3. That's the mean. So what will be the mean derivation? X minus 1 minus 3 will be minus 2, minus 1, 0, 1, 2. If you square it, 4, 1, 0, 1, 4. Alright? F of it, F times this, 8, 1, 0, 1, 8. Let's add this together. Summation 16, 17, 18. That's 18. So our variance is going to be summation f x minus mean squared over summation f. There will be no square root there. So variance is going to be, this is what is 18 over, what is the summation f over 8. So 2 here is 9, 2 here 4. 9 over 4, we have that in the option B. That is the answer. Given that x is cos 30 and y is sin 30, evaluate without using a mathematical table or calculator x squared plus y squared divided by y squared minus x squared. Now, you were asked to answer this question without using calculator. So you need to know how to get your cos 30, your sin 30, how to get all of that without using calculator. Now, if you have not seen my video on how to get those special angles without using calculator, then check the description to this video. You will see it there. Now, sin 30 is actually 1 over 2, which is 0.5. And cos 30 is root 3 over 2. This is all you need. So this is your y, and your sin 30 is, no, this is your x, rather x is cos 30, and this is your y. So before I go ahead to solve this, let me prove this to you in very quickly. So let me show you very quickly. This is a shortcut you can use to know those special angles. This is your theta, sine, cos, and tan. 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Now, your sin 30, that's the only one you need to master, is 1 over 2. That is R. Sin 30 is 1 over 2. So all you just need to do is put root on this one, square root of 1 over 2. So here, just put root 2 over 2. After 2, what's next? 3. Root 3 over 2. Root 4 over 2. Then what you have before 1 is 0. Root 0 over 2. That is it. Now, to get your cosine, reverse everything that you have for your sine. Reverse it here. What do I mean? What's the last value here? Root 4 over 2. I'm going to put it here. Root 4 over 2. Root 3 over 2. Root 2 over 2. Root 1 over 2, root 0 over 2. And to get my tan theta is going to be sine theta divided by cos theta. So I'll just divide this by this. It's going to give me this. This by this gives me this. This by this. So root 0 is 0 divided by 2 is 0. Cos 2 times 0 is 0. So 0 divided by any number is 0. This divided by this is going to give me 1 over root 3. This divided by this, they are the same, will give me 1. Then this divided by this will give me root 3. Then Root 4 is 2. 2 divided by 2 is 1. 1 divided by 0, because here is equal to 0. 2 times 0 is 0. So 1 divided by 0 is undefined. So here is going to be undefined. So that was how I got my cos 30 to be root 3 over 2. So this is cos 30 root 3 over 2. Now that being said, so all you just need to do to answer this question is to slot in the value. So x squared, what is our x? X is root 3 over 2 squared plus, what is our y squared? Y is 1 over 2 squared divided by y is what? 1 over 2 squared minus x is what? Root 3 over 2 squared. So while we are doing that, now let's complete that. So this is going to be our x. So if I'm going to open this bracket, it's going to be root 3 squared over 2 squared, that is 4, plus 1 squared is 1, 2 squared is 4, all over 1 squared is 1, 2 squared is 4. You remember this squared is for what is up and down, minus this will be root 3 squared over 4. Root 3 squared, so this cancels this. Alright, so if that is that, my answer is going to be, I'm going to open this up because my square root 3 squared, so the square cancels the square root, so I have 3 over 4 divided by, or 3 over 4 plus, then this also from here. So root 3 squared, yes, divided by 4 plus, then I have 1 over 4, all divided by, I'll come to the denominator, 1 over 4 minus this, we cancel this, 3 over 4. And that would be what? So since I have the same denominator, all I need to do is to add the numerator. So I'm going to have 3 plus 1 over 4. That's for my numerator is 4 over 4. And that's going to be 1. While for my denominator, I will just say LCM is 4. All right. 1 minus 3. 1 minus 3. And that's going to be what? So that's going to be minus 2 over 4. That's minus half. So now I have 1 divided by minus half. What's going to be my answer? That's 1 over 1. So it will be 1 over 1 times 2 over 1. Remember there's a minus. So the answer is 2. So the final answer will be minus 2. Minus 2. So that's the answer to this. So if you press this in your calculator, the answer is going to be minus 2. That is the answer to the question.
When asked to answer this question, all you need to do is convert this to, so 2 divided by 64 divided by 125 close bracket raised to power minus 2 over 3. According to the law of indices, you convert this to positive power. So that's going to be 2 divided by, so this 2 is the same thing as 2 over 1 divided by 1 all over. So if I want to change this negative power to positive, I'll find the inverse of everything. That will be 1 all over 64 divided by 125, then all raised to power 2 over 3. That's going to be 2 over 1 divided by 1 all over. Then this denominator of this fraction, this power, the denominator will form a root over this fraction. Then the numerator will form a power. That is 3 root 64 over 125, all raised to the power of 2. If you have not seen my video on the laws of indices, I dropped the description I dropped the link in the description. You can get the link to the video. It will help you. So let's proceed. So that's going to be 2 over 1 divided by 1 all over. Cube root of 64 means what will I multiply by itself 3 times? That will give me 64. The answer is 4. 125, cube root of 125 is 5. What will I multiply by itself 3 times? That will give me 125. 5 times 5 is 25 times 5 is 125. So 25. Yeah, 25, 10, 125. So it's 125. Let's proceed. Now, we solve this. It's still raised to power of 2. So that's going to be what? 2 over 1 divided by 1 all over 16 divided by 25. Okay? And that would be 2 over 1 divided by 1 divided by 16 over 25. This one is 1 over 1. And that's going to be 2 over 1 divided by 1 over 1 times, if I change this division to times 25 will go up, the numerator comes down. 25 over 16. So that's going to be 2 over 1 divided by 25 over 16. Now I'm going to do the same thing. I'm converting this division to multiplication. This will go up, this will come down. So I'm going to have 2 over 1, all right, times 16 over 25. My answer is going to be 32 over 25. So that is the answer to this question. 5 over 8 of 2 raised power 2 or number 1 over 2 minus 3 over 4 divided by 3 over 5. According to board mass, we are going to calculate the bracket first. If there's anything like that, there is none, we go to off. So we are solving this. That will be 5 over 8. Off means times, we convert this to improper fraction. 2 times 2, 4 plus 1, times 5 over 2 minus 3 over 4 divided by 3 over 5. So we can solve this. This will be 25 over 16 minus this and this. So after the off, division is next. So we divide this. If we are dividing this, this we change to times. The denominator goes up, numerator comes down. So that will be minus 3 over 4 times 5 over 3. 3 cancels 3. So we have 5 over 4. That's going to be 25 over 16 minus 5 over 4. Our LCM is 16. 16 in 16 is 1 times 25. 25 minus 4 in 16 is 4 times 5, 20. So the answer is going to be 25 minus 20 is 5 over 16. That is the answer to the question. You should simplify 3 minus 2 divided by 4 over 5 plus 1 over 2. If you are going to follow the board mass, which is bracket of division, multiplication, division, addition, and subtraction. So we are going to start with division. Alright? So this, you are starting with this divided by 1. So you're going to have 2 over 1 divided by 4 over 5. That will be 2 over 1. If you change division to multiplication, that's the only way you could solve it. You change to multiplication, denominator will come up to become numerator, denominator goes down. 2 over 1 times 5 over 4. That will be 10 over 4. 2 here 5. 2 here 2. 5 over 2. So you are back to 3 minus, this 3 over 1 minus 5 over 2 plus 1 over 2. Our LCM is going to be 2. Alright? 1 into 2 is 2 times 3 is 6 minus 2 into 1 times 5, 5 plus 2 into 1 times 1, 1. So that will be 6 minus 5 is 1 plus 1, 2 over 2. And if you divide it, your answer will be 1. Do we have 1 in the option? Yes. 2 over 3 minus 1 over 5 in a bracket minus 1 over 3 of 2 over 5 all divided by 3 minus 1 over 1, 1 over 9. According to board mass, you are going to open the bracket first. We open the bracket first according to the rule of board mass. So that will be what? 2 over 3 minus 1 over 5. Our LCM is going to be 15. 3 in 15, 5 times 2, 10 minus 5 in 15, 3 times 1, 3. That's 7 over 15. Alright? So minus, we have 1/3 of 2 over 5. 1/3 of means times 2 over 5. So we need to solve all the numerator first, get the final answer, and then we come to the denominator. So that will be 7 over 15 minus 2 times 1 is 2 over 15. And that will be what? 5 over 15. That is the what? That is the numerator, because we've been able to solve this bracket minus 1 over 3 of this. The 1 over 3 of 2 over 5 gave us this. So our numerator is 5 over 15. This is our numerator. Now, we now go to the denominator, which is what? 3 over 1 minus 1 divided by 1 number 1 over 9. That's the same thing as 3 over 1 minus 1 over 1 divided by 9 times 1 is 9 plus 1, 10 over 9. Alright, that's going to be 3 over 1 minus 1 over 1 times 9 over 10. We will solve this first. That will be 3 over 1 minus 9 over 10. So we find our LCM 10 here, 10 times 3, 30 minus 10 here, 1 times 9. That is 21 over 10. 21 over 10. So let's combine it with the numerator. So we're going to have 5 over 15 divided by 21 over 10. That will be 5 over 15 times 10 over 21. 5 here 2, 5 here 3. So 2 times 5, 10 all over 3 times 21 is 63. 10 over 63. 10 over 63. That is our final answer.
Quickly look at these questions on algebra. Given that P equal to Q equal minus 5 and R equals minus 4, evaluate 3P squared minus QR minus R cubed. We're given option 8, 101, B, 77, C, 51, D, minus 27. Now, here's the question. Given that P equals 2, Q equals 5, and R equals minus 4, evaluate 3P squared minus Q squared minus R cubed. You were given the following options. Option A, 101, 77, 55, and minus 21. So let's look at what are we supposed to do. Given that P is, so these are the values of your P. So we write out the question 3P squared minus Q squared minus R cubed. And then we are going to, wherever you have P, you slot in the value given. So we have 3 into brackets. P is 2 squared minus Q squared. Q is minus 5. Please take note of this minus and then take note of this minus. So you have minus 5 squared minus, then your R is minus 4. Your R is minus 4. So you have minus 4 cubed. So this is going to be 3 into bracket 2 squared is 4 minus 5 squared means minus 5 times minus 5. That's going to be minus times minus is plus. 5 times 5 is 25 minus 4 raised to power 3 means minus 4 times minus 4 times minus 4. So the first minus times the second minus will be plus. That plus times the last minus will be minus. 4 times 4 is 16 times 4 is 64. Right, so we've been able to sort that. The next thing, 3 times 4 is 12 minus 25. Minus times minus is plus 64. So if you're going to add that using your board mass, you add this and this, the plus together first. Plus 12 plus 64, that gives us 76. 76 minus 25 is going to give us 51. And that is the answer. So we have 51 in the option. I hope that is clear. Now let's discuss change of subject of formula. This is a question. If P equals square root of QR into brackets 1 plus 3t over R, make R the subject of formula. How do we answer this question? The first thing you want to do, because we're going to make sure that these 2R, we bring them together and then we bring them out. So what are we going to do? The first thing is to remove this square root. How do we remove square root? We are going to square both sides of this formula. What are the two sides? P, this is a side before the equality sign, and this other side is another side. So P equals to QR into 1 plus 3t over R, all right, squared. So we square both sides. If we square this side, and we square this side, this square we cancel this square. So we have P squared equals QR into 1 plus 3t over R. Now we are going to open this bracket. This 1 is the same thing as 1 over 1. This 3t is the same thing as 3t over R. To make opening the bracket easier. So P squared is going to be QR times this is going to be QR plus QR 3t over r. So this r can cancel this r. This is over 1. So we have p squared equals to qr plus 3qt. Mind you, we want to make r the subject of formula. So what we can do here is to factorize this. All right. Okay, so what we can do now, what can we do to make this r? So we're going to make this move to this side. So we have p squared minus 3qt equals to qr. Now we divide both sides by q, right? Then we have r equals to p squared minus 3qt all over q. That is the answer. So by this, you've been able to make r the subject of formula. So the final answer is r equals p squared minus 3qt over q. So that's the answer. Let's look at another example. Now this question says if x over a plus 1 plus y over b equal 1, make y the subject. So we are asked to make y the subject of formula. X over a plus 1 plus y over b equal 1. We find the LCM. That's the first thing to do. LCM is going to be this multiplied by this. So we are going to have a plus 1 brackets b. So how many times will this go in this? It's going to be b times. So this here is b times x, bx, plus b here is going to give us this. So multiply by y, it's going to be plus y into bracket a plus 1, all equal 1. So if we open this bracket, bx plus ay plus y all over, if we open this bracket, ab plus b all equal to 1, ab plus b equal 1. So we cross multiply to linearize it. So that's going to be bx plus ay plus y equals to ab plus b. Remember, we are making y the subject. So we make everything that have y to be at the same side. Everything without y goes to the other side. So that's going to be ay plus y equals to ab plus b minus bx. So we can factorize here y into bracket a plus 1 equal to b is common to everybody here. So we factorize as well. b to a plus 1 minus x. Then we can divide both sides by coefficient of y, a plus 1, a plus 1. So this we cancel this. Y is therefore going to be b into a plus 1 minus x all over a plus 1. That is the answer. This question says express the square root of 0.00144 in the standard form. So we are asked to express, there are two questions in one here. You are expressing the square root of this value in standard form. So the very simplest way to answer that question is to convert this to standard form first, and then you find the square root. So let's do that. So the number is 0.000144. If I'm going to convert this to standard form, that will be easy for me to find the square root. I'm going to do this. I'll move the decimal 1, 2, 3, 4, 5, 6. That's going to be 144 times 10 raised to the power minus 6. What is a minus 6? Because I'm driving forward. I'm moving forward. It's going to be minus 6. So there's an acronym you can use to remember. Forward is minus, backward is plus. FMBP. Right? Going forward is minus, coming backward is plus. Now, since I've gotten that, now I can find the square root of 144 times 10 raised to the power minus 6. That's the square root of 144 is 12. The square root of 10 raised to the power minus 6 is 10 raised to the power minus 3. How do I know? 10 raised to the power minus 3 multiplied by 10 raised to the power minus 3. All you need to do is to pick one of these 10 and you have the power. If you have the power, it will be minus 3 plus minus 3, that's minus 6. And that's this. So the square root of this 10 raised to the power minus 6 means what will I multiply by itself that will give me 10 raised to the power minus 6, and that's this. So the square root of this is this, and then we have it. So now Do I have this in the option? No. The reason is because this is not absolutely in standard form, because in standard form number, this number should be between 1 and 9.9, not up to 10, but 12 is more than 10. So I'm going to convert 1.2 to standard form. It's going to be, or I'm going to convert 12 to standard form to be 1.2 times 10 raised to the power 1, then multiplied by 10 raised to the power minus 3. That would be 1.2 times 10 raised to the power my 1 minus 3. That's 1.2 times 10 raised to the power minus 2. Do we have that in the option? 1.2 times 10 raised to the power minus 2. The option is C. That is the correct answer. If 3 over 2x minus 2 over 3x equals 4, solve for x. So if we are asked to solve for x, very simple algebra, this is what you do. 3 divided by 2x minus 2 divided by 3x all equal to 4. You find the LCM of this. The LCM is going to be 6x. All right, so how many times will 2x go in 6x? That's 3 times. I'll use it to multiply this 3. So 3 by 3 will be 9 minus 3x here. That will be 2 times 2, 4. All equal to 4. 9 minus 4 is 5 over 6x equal to 4 over 1. I'm going to cross multiply. So if I cross multiply, 5 by 1 is 5 equal to 6x by 4. By 4. So that's going to be 5 equals to 24. X, I'll divide both sides by the coefficient of x, which is 24. 24 divided by 24. My x is going to be 5 over 24. Is that in the option? Yes. That is the answer to the question. Second question, if I have 5 over 6x minus 3 over 8x equal to 6. What's going to be my answer? 5 over 6x minus 3 over 8x equals 6. The LCM is going to be what? 8x times 6x, that will be 48x. But there is a lower number that forms the LCM. That's 24. 6 can go in 24. 8 can go in 24. So 24x. 6x in 24x. 6 will go here 4 times. 4 by 5, that will be 20 minus 8x here 3 times. 8 will go in 24 3 times. 3 by 3, that's 9. So I'm going to have all equals to 6. And so we're going to have 20 minus 9 is 11. 11 divided by 24x equal to 6 over 1. I'll cross multiply. So I'm going to have 24x by 6 equal to 11. So I'll divide both sides. 24 by 6, it's going to be 24, 12, 13, 14. So that is 144x equals 11. I'll divide both sides by coefficient of x. Divide by 144. And that makes my answer. So my x is going to be 11 over 144. That is the answer to the question. I'm talking about circles as part of your revision for the mathematics exam. But I will very quickly, I'll take you the definition of parts. So in a question you see, calculate the area of a sector, calculate the area of the segment, calculate the length of a chord, calculate the length of an arc. If you do not understand the meaning of all of these, you cannot answer the questions. All right. So now I'm going to quickly draw the diagram of the circle for you, and I will label all those parts. I will try to learn together. Is that okay? Welcome to class. So the first thing you want to do is to identify. So this is a circle. I'm sorry, it's not to scale, so it's not exactly perfect circle, but then you will still understand all that I'm going to explain to you. Now, the first thing you want to know is the boundary around this circle. So the first term I'll be talking about is the circumference of the circle. Circumference of the circle. So what is circumference? Circumference of a circle is the boundary around this circle. Going around, that's the boundary. So it's also called the perimeter. All right, for a plane shape, they call it the perimeter. The perimeter of the room, it includes the length, all right, the two lengths and the two breadths. So this is the length of this room, then the breadth. When you calculate everything around the boundary of the room, all right, that is the perimeter. So, but when you talk about circles, you talk about circumference. So, is the boundary around a circle. That's the first thing. The next term you need to talk about is the diameter. What is the diameter? The diameter is a line that runs through from a part of the circle to the other part of the circle, the circumference, dividing the circle into two equal halves. So if you take an orange and you cut it into two equal halves, okay, that line that cuts it into two, that is the diameter. So you can as well say diameter is half of the circle, right? So diameter is the line that cuts through the circle, dividing it into two equal halves or two equal parts, right? So as it is now, my AOB is my diameter. So e.g. line AOB, that is the line that cuts the circle into two equal halves. The next thing you need to talk about is the radius. The radius is the what? The radius is the distance from the center of this circle to any part of the circumference of this circle. I repeat, if I draw a line from this circle, from the center of this circle to any part of the circumference, that is the radius. All right? So a line drawn from the center of the circle to any part of the circumference could be downwards, it could be sideways, in any direction, it could be this direction, but it's all the same. If this is a perfect circle, the radius is the same across both. So radius is the line drawn from the center of a circle to any point in the circumference. Any point in the circumference, okay, from the center to any point of the circumference. Now that's not all. You can also say radius, it is half of a diameter, So if I cut this diameter, this is a diameter half of a circle. If I now cut the diameter into two equal halves, I have the radius. So radius is half of a diameter. The next thing we talk about is the arc. Now the arc is any part of this circumference. So if this circle, this circumference, if I take a part out, that means EB, the line from E to B, BE, it's an arc. So an arc is any part of the circumference. Any part that is cut out of the circumference. For example, let's look at the arcs we have here, e.g. AE. The line AE is an arc, the boundary EB, those are arcs, okay? CD, ETC, those are arcs. Now let's talk about a chord. What is a chord? A chord is a line that joins or a line that connects two parts or 2 points on the circumference together. 2 points on the circumference. A line that connects 2 points on the circumference other than the diameter. This radius is connecting circumference to the middle, not to another part of the circumference. But this line connects this part of the circumference, this part C and D, connecting it together. So the chord is a line other than the diameter connecting or joining 2 points on the circumference. e.g. line CD is a chord. So this is a chord CD. If I choose to paint this portion now, that painted portion is the segment. So let me label this diagram. This is the segment. This is my radius. This is the diameter. Right? So this line CD, this is the chord. While the content that is inside the chord is the segment, then this portion can be referred to as the sector. So we're going to define all of that. Segment. A segment is this portion that is bounded by a chord and an arc. You remember CD is an arc. So chord is a line other than the diameter connecting 2 points on the circumference, e.g. the line CD. So this line CD is a chord. It's connecting these 2 portions of the circumference other than the diameter, right? Then a segment is an area of the circle or a portion of the circle bounded by a chord and an arc. So this is a chord, this is the arc. C to D is an arc. So that portion that is bounded by a chord and a segment and an arc, rather, that is the segment. So I can label this. This is an arc. Right? This portion is an arc. 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 Any part, this portion is an arc. Right? So those are arcs. All right, so that's a segment. Now let's talk about a sector. What's a sector? A sector is a portion or area of the circle bounded by 2. So this is a sector bounded by 2 radii. So this is a radius. This line is radius. This line is radius. 2 radii. Radii is the plural of radius. 2 radii and an arc. So look at it. This is a radius. This is an arc. EB is an arc. So this is a sector. A portion of this circle bounded by 2 radii and an arc is called the sector. So the next thing we talk about now is we're going to be discussing the formulas. What are the formulas you use to calculate the area of a sector? You use to calculate the area of chord and all of that. So you can have a situation where, so I'm going to draw another diagram and then we take it on. Next thing we talk about, let's look at formulas that you're going to use to do these calculations on circles. So the first one is circumference of a circle. The circumference of a circle, the formula is 2 pi r. 2 pi r, you know what r is, the radius. The pi is a constant, which is equivalent to 22/7 or 3.142. That's the value of your pi. Now the second one is area of a circle. The formula for area of circle is pi r squared. Pi r squared. Now you could get into the exam hall and there will be a kind of you could get into the exam hall and you'll be confused. Oh, which one is pi r squared? Which one is 2 pi r? So I'll quickly give you a shortcut that you can use to easily recall which is pi r squared, which is 2 pi r. How do you remember which is pi r squared? You know, area. This is A for area, right? So all you need to do is, instead of drawing this line at this middle of your A for area, just move that line upward to become pi. So A, area, pi. I move the A upward. So that means for area of a circle, it is pi that starts the formula. So it's pi r squared. Pi r squared. Right? While for my circumference, it is for circumference 2 that begins it. So this 2 pi r, if I shade off a part of this 2, I have a C. If I twist it to the other side, I have C. That is circumference. So for circumference of a circle, it's 2 pi r. I hope that is clear. Number 3. The next thing we talk about is length of an arc. Length of an arc. The formula for length of an arc is theta over 360 times 2 pi r. Remember, length has to do with distance. So when we are dealing with distance, perimeter, the size, the distance, we are going to, and it has to do with circles, we'll be dealing with 2 pi r, circumference, distance, 2 pi r. But when we are dealing with area, calculating the area of sector, area of this, area of that, we deal with pi r squared. From this area, pi r squared. But if we are dealing with length of this, circumference, length, distance, we are dealing with 2 pi r. So the length of an arc is theta over 360 times 2 pi r. While number 4, the area of a sector. You remember what a sector is and an arc. So this is an arc, CD is an arc, EB is an arc. A sector is this portion that is shaded, all right? So, but it's subtended at the center, so it has an angle here, all right? So a sector is a portion of the circle bounded by 2 radii and an arc, and it subtends at the center, at an angle at the center, at an angle at the center. So there's always an angle theta here. So for that sector. Now, to talk about the area of this sector, it's going to be theta over 360, times pi r squared. Pi r squared, not 2 pi r now, pi r squared, because we are dealing with area. Number 5, let's deal with the perimeter of a sector. What's the perimeter of a sector? This is a sector. Perimeter of a sector means the boundary around this sector. So when you want to calculate it, the perimeter of a sector, it is the length of this arc added to this line, which is radius, another radius here. So 2 radius and 1 length. So the perimeter of a sector will be 2r plus L. 2r plus length of an arc, the length of this arc. That gives us the perimeter, the boundary around this sector. So 2r plus L, that's 2 of radius plus length of an arc. Number 6, you could be asked to find the length of a chord. The length of a chord. So how do we find the length of a chord? Next, we want to talk about how to calculate the area of this shaded segment. You remember this shaded portion is the segment. A segment is bounded by an arc and a chord. Now, if they ask you what is the area of this segment, all you need to do is this portion A, B, C is a sector. And then if you have line AB, this line A to B to C, the straight line, is a triangle. So that means what makes up a sector, this is a sector A, B, C, like this, that's a sector. What makes up a sector is actually a triangle, this is a triangle, and the segment. So if you have the segment and a triangle, you have a sector. So if you are asked to find the area of this shaded segment, the area of the segment is going to be what? Area of a sector minus the area of triangle. Because the area of this sector is addition of area of a triangle, area of a triangle and the segment. So this is what I'm saying. So area of sector, this area of sector that I have here is also the same as area of triangle plus area of segment. So this segment and this triangle, if I add their areas together, I have the area of the sector. So if I am now asked to find the area of the segment, what do? So to find this area of segment, I will move this here. It will be area of sector minus area of triangle. So that brings us to the area of segment is equal to area of sector minus area of triangle. So look at it very well. Area of the segment will be area of sector minus area of triangle. So now I'm going to give you, we have already discussed area of sector. Now we have the area of segment. So how do we get the area of a triangle in a circle? To get the area of the triangle, that's the seventh, area of triangle in a circle, you can use half base times height, which is the regular area of circle, or area of triangle. You can also use, or area of triangle is also half r squared sine theta. Half r squared sine theta. Half r squared sine theta. So that's what you can do. Then let's talk about, so if they ask you for the length of this chord, to be able to get the length of this chord, you are going to need to use this triangle. The triangle to find the length of the chord. So for example, if I divide this into 2, this forms a right angle here. So if they ask you to find the length of a chord, maybe they've given you the here. You remember this portion is the radius. So maybe this is the radius, this is a radius also. So, and maybe you have been given a line here too. You can, this is a right angle triangle. So from this radius and this line, you can get this third line using either the Pythagoras theorem. Okay, you can get this third line. So once you get the third line, that third line will be half of the chord. So whatever you get here, multiply by 2, it will give you the length of this complete chord. I'm going to do an example very quickly, and you will understand what I'm saying much better. Here is a question. A chord is 2 centimeters from the center of a circle. A chord is 2 centimeters from the center of a circle. So the first thing you want to do is you're going to draw a circle. Okay? So they said a chord is 2 centimeters from the center of a circle. This is the center of the circle. All right. So this is a chord. It is 2 centimeters. So I don't really need this. I don't need this. So look at it. A chord is 2 centimeters from this center of the circle. If the radius of the circle is 5 centimeters, you remember radius is from the distance to any portion of this circumference. So I can as well say this is my radius because it's the line from the center to any portion of the circumference. The radius of the circle is 5 centimeters. So here is 5 centimeters. And of course, here too is a radius. So it's 5 centimeters as well, because it's the line from the center to any portion, any part of this circumference. So it's also 5 centimeters. So they said find the length of this chord. The length of this chord. How are we going to find the length of this chord? I explained it earlier. You can use this triangle. You already have here as 2 centimeters. You have here 5. You can find x. Whatever your x is, that also will be what is here, because they are the same. One of the theorems. So after this revision class, I'm going to go into the second part where I'll be talking about the theorems, the circle theorems. Okay, one of the theorems says that the line drawn from the center of a circle to meet a chord will divide that chord into 2 equal lines or parts. So if the length of this chord is 10 centimeters, this line coming from the center will divide into 5. All right, so that means whatever I get for my x here, I'm going to multiply by 2 to give me the length of this chord. So to do that, if I bring out this triangle, I'm going to have a right angle triangle. Here is x, here is 2 centimeters, and here is 5 centimeters. So if I face this portion, this is the opposite, this is the adjacent, this is the hypotenuse. So I'm going to use, to find this adjacent, hypotenuse squared, this Pythagoras theorem, is hypotenuse squared equals to opposite squared plus adjacent squared. So for me to find this adjacent is going to be hypotenuse squared minus opposite squared. So what's the hypotenuse? 5 squared minus 2 squared is equals to x squared. All right, so my x squared is going to be 25 minus 4. X squared is going to be 21. So I'll find the square root of both sides. This cancels this. So my x is root of 21 centimeter. But that is not the length of the chord. The question says find the length of the chord. So I'm going to, this is 21 centimeter multiplied by 2 so that I could get the length of the chord. So the length of the chord will be 2 times root 21. And that's going to be 2 root 21 centimeter, not root 42. Because 2 cannot multiply what you have under the square root. That's the sod, the rule of sod. So the answer is 2 root 21. Do we have that in the option? 2 root 21 centimeters. That is the length of the chord. Let's look at another example. Number 2, an arc of a circle of radius 2 centimeters obtained at an angle of 60 degrees at the center. Find the area of the sector. So this is the diagram. They said an arc of a circle of radius this. So this is the, so we can say this is an arc, and this is radius 2 centimeters. You remember this, the radius is from the center of a circle, that's not up to the center. So let's try to draw it down a bit. Yeah, to any part. So this is 2 centimeters, and they said an angle of 60 degrees and an arc of a circle of radius 2 centimeters subtends an angle at the center. Find the area of this sector. This is a sector having 2 radius and 1 arc. So the formula for area of a sector is what? Theta over 360 times, is it 2 pi r or pi r squared? Because we are dealing with area, is pi r squared. So times pi r squared. So now, if you check the options, pi is in the option. So that means you are doing in terms of pi. We are not going to use pi as 22 over 7 or 3.142. Rather, we leave the pi in the expression. So our theta is 60 degrees. So theta is 60 degrees. Okay. Our radius is 2 centimeters. And because in the option, you are seeing centimeters, so you are not converting that centimeter. It's still going to be centimeters. So area of the sector will now be what? Area will be theta 60 over 360 times pi times r is 2 squared. That's 2 times 2. This cancel this, 6 here 1, 6 here 6. So the area is equal to 2 times 2, 4 pi over 6. 2 in 4, 2. 2 here 3. So the final answer is 2 pi over 3 centimeters squared. Do we have that in the option? 2 pi over 3 centimeters squared. Option A. That is the correct answer. Can you see these things are not difficult? I'm going to take a final question and then I'll drop the question on the screen, on the board. I want you to go to the comment section after calculating it and drop your answer to the question at the comment section to be sure that you have really understood what I gave on the board. So let's go there. The question says in the figure below, the area of the shaded segment is dash. What's the area of this shaded segment? You can pause the video and attempt the question. All right, welcome back. Let us try to attempt this question together. So this is a sector, and in this sector you have a triangle, you have the segments making up the sector. It said in the figure below, the area of the shaded portion, the area of this segment. So to know the area of this segment, all you need to do is to find the area of the entire sector minus the area of the triangle, all right? And then you get the area of the segment, which is what I have here. Area of segment is area of sector minus area of triangle. So let's try. So the first thing we have to do is let us try to calculate the area of a sector. We're going to need to calculate the area of the sector, right? Look at it in the figure below, the area of the shaded segment. This shaded segment is what? So area of a sector minus area of, so let's find the area of sector. Area of sector will be what? theta over 360 times pi r squared. And our theta is what? 120 degrees, right? Our pi is in the option, so we're using it straight. So the area of sector will be 120 over 360 times pi times our radius is 3. 3 times 3, that's 9. So this cancels, this is 1 over 3. 3 cancels 3, that is 3 pi. So the area of the sector is 3 pi. Now let's try to find the area of the triangle. There are two formulas you can use to find the area of the triangle. You can use half of base times height, but we need to find the height to be able to answer this question. So you need to find the half of base times height, and you can also do half r squared sine theta. Half r squared sine theta. So since we do not have the length of this chord, and we don't have the length of the chord, we don't have the length of the distance from here to this chord. So let's use half r squared sine theta. So area of circle, area of triangle rather, is half r squared sine theta. And that's going to be what? Half times, what's the radius? 3 squared. That's 3 times 3 times sine 120. Sine 120 degrees is the same thing as sine 60, which is root 3 over 2. All right, so if that is the case, you are going to have half times 9 times root 3 over 2. That's sine 120. All right, so if you multiply this, it's going to be 9 root 3 over 2 times 2 is 4. All right, 2 times 1 times 2, that is 4. So we have 9 root 3 over 4. Now, if you are going to now bring it back to get the area of the shaded segment, area of shaded segment will be what? Area of shaded segment will be what? Area of sector minus this. So that would be 3 pi minus 9 root 3 over 4. Is that in the option? So let's factorize this. What is common to these two sides? 3 is common. That's going to be 3 into bracket pi minus 3 to factorize 9. That will be left with 3. 3 root 3 over 4. So our final answer is 3 into bracket pi minus 3 root 3 over 4. Is that in the option? 3 into bracket pi minus 3 root 3 over 4. Yes, that is option C. So that is the answer to the question. So about circle theorems. In the first part of this video, I've discussed the first aspect of circle geometry, how you can identify your segment, the chord, the arc, the sector, how to find the length of an arc, how to find the area of a sector. I've simplified everything. If you have not seen the video, I'll drop the link in the description to this video. But today I'll be talking about the circle theorems. So what are the theorems that you'll be using to answer questions? And I have simplified these theorems for you. So very quickly, let's delve in and check so that you will be able to answer questions effectively in your WAEC exams and in your NECO exams. Now, the first theorem I'll be talking about, when you have a circle, and then remember, this is the center of the circle, and then this is a chord. This is a chord. This is a chord. I discussed the meaning of a chord in my first video. Now, the first theory says a line drawn from the center of the circle to meet the chord, right? To meet this chord forms or is perpendicular to the chord. It's perpendicular to the chord, meaning that it forms angle 90 degrees to this with this chord, all right? And not that alone, it divides this chord into 2 equal halves. Divides the chord into 2 equal halves. So the theorem says a line drawn from the center of the circle to meet a chord divides the chord into two equal halves. That's number one. Number two, the line is perpendicular to the chord. Let's label the chord AB, to the chord AB, that is forms angle 90, forms angle 90 degrees. So the angle here is 90 degrees, right? From this center C, that's angle 90 degrees. Now, once that is settled, how can we apply this in answering questions? Now, the next thing, before we go to the next one, if I draw a line here, you recall that this line is the what? Is the radius. Why is it the radius? Radius is any line drawn from the center of a circle. Yes, let me adjust this circle. Forgive the size of my circle, it's not accurate. All right, from the center of this circle to any part of the circumference is a radius. So this is a radius. So if this is a radius, that means the size of here will also be equal to the size of here. So the length of here is the length of here. Is that okay? So this is a triangle. So from this theorem, angle 90 degrees here. So you can, if you are given the value of here, you can do Pythagoras theorem here to get the length of the chord. Let's look at the second theorem, theorem number 2. So this theorem 1. Theorem 2 says that if I have a circle and then I have this, yes, the angle here is twice of the angle at the circumference. So this theorem says the angle at the center, so this is the center C. So the angle at the center C is twice the angle at the circumference. The circumference is at this point, or the angle at this circumference, at the point there, at the top here, this angle x. So this is 2x. So if here is 30 degrees, here will be 60 degrees. And if here is 100 degrees, that means here is half of what you have here. Number 3, if I have a circle, and then I have a diameter that cuts the circle into 2 equal halves, and then I have a chord here, I have another chord here. Pardon my line, yeah. So the theorem says this is a line, the diameter, this is a chord connecting to the diameter at this point, this is another chord here. The angle between the two chords will be 90 degrees. So when two chords meet at the diameter, they form 90 degrees. So if I have ABC, all right, so my angle ABC is 90 degrees because at this diameter, so the chord, these are two chords joining at this angle and it make up so 90 degrees. So here, if I label here A, B, C, D, and I've said here is twice of here, so that means my angle ACD is equals to 2 times of angle is 2 times of is twice of 2 times angle ABD. You remember the meaning of this, it means angle, and that means the angle is at the center C. So ACD. So ACD is 2 times of ABD, ABD. That means this sign means my angle is on B, All right. So number 4, if I have a circle like this, if I have a circle, and I have okay, so let's take this. I take this, take this, take this, and I take this. Now let me not make it a perfect quadrilateral. Yeah. So in this circle, if I have A, B, C, D, the theorem says this angle and this angle are supplementary. So angle ABC is supplementary to angle ADC. And what's the meaning of that? It means the angle, that means my angle ABC plus my ADC is equals to 180 degrees. So if I add this to be 80 degrees, then also same here and here, if I add the two together, it will be 180 degrees. So my BAD also, angle BAD plus angle BCD is 180 degrees. Number 5. If I have a circle and I have this, if I have a chord of equal length and the center here, the distance from here to this chord to the center is the same as the distance here. So here and here are the same. So look at this. If I have two chords, let's say this is AB and CD. So if there are two chords equal in length have the same distance, from the center of the circle. So the distance between here and here and here and here are exactly the same, given that the length of this chord and the length of this chord are equal. I have a circle here, and then I draw a line like this. And then I have an angle here, I have an angle here. The rule says whatever is here and here, they are the same. X and X. Why? Because both of them are angles within the same segment. So the rule says angles in the same segment are equal. So this, if I draw a line here, a chord, that is a segment. So the angle in this segment and this, they are exactly the same. So angles in the same segment are equal. If you have a circle and you have a tangent here, you have a second to the last, a tangent, and then I have a triangle, something like this. All right. So the rule says the angle between this chord and this tangent, the angle between this chord and this tangent is equivalent to the angle at this point. They are alternating, the alternating segment. They alternate. All right. The angle between this chord to this tangent that it makes is equal to this. And then the same thing here, the angle from here, from this chord, that it makes to this tangent is equivalent to here. So this is y. So the rule here says the angle a chord makes with the tangent at the point of contact. This is the point of contact. At the point of contact is equal to the alternate, to the angle in the alternate segment. Alternate segment. So this angle from this chord to the tangent, all right, is equal to this angle. And then this angle here is equal to this angle here. And lastly, let me have this. When I have a circle, then there is this. All right, so there are two tangents that are bent and they meet at this point. Okay, the rule makes us to understand that the distance of here, these two tangents that are drawn to meet at this point, they have the same distance from the circle. So if here is A, B, C, then D, E. So it means that the line AB is equal to line AD. So the distance from here to here is equal to the distance from here to here. So that is what the rule says. Now we already have 9. So let me quickly do a run through from the beginning. Let me do a run through. Number one, when you have a circle and then you have a chord from the center of the circle, a line drawn from the center of the circle to this chord, we divide this chord into 2 equal halves, and then the line is perpendicular to the chord, meaning it forms angle 90 degrees. Number two, when you have a circle and then you have an angle at the center and at the segment or at the circumference, the angle at the center is twice the angle at the circumference. For this, when two chords are connected to the diameter, this is connected to a side of the diameter, this is connected to another side of the diameter within the semicircle, all right, they form an angle 90 degrees at the point of connection. Then when you have a quadrilateral in a circle, the two opposite, so segments, these segments, they are opposite segments, they are supplementary. All right, angle in these opposite segments are supplementary. Okay, meaning you add it up to give you 180 degrees. The angle here plus the angle here adds up to give 180 degrees. Then if you have two chords of equal length, all right, drawn on each side of a circle like this, the distance of this chord from the center is exactly equal to the distance of this chord from the center. Then when you have this, angles within the same segment are equal. So here is x, here is x. Then here, if I draw a tangent, the line that runs from the center of a circle to this tangent is perpendicular. The line is perpendicular to the tangent. The tangent is this line, so we can call it AT or AB. The AB is a tangent. So line CD is perpendicular to line AB, to line AB. And then the next one, the angle. So here, this is a chord, this is a line, this is a chord, this is a segment, this is another chord here, this is a third chord here. Now for this chord, the angle from this point, this line of the chord to the tangent, all right, is equal to this angle on the alternate segment. So this This is another segment, the angle here. Please take note, this angle is within the triangle. This is outside the triangle connecting to the tangent. So both of them are not within, not the one within here, but the one outside here. Then the one outside here is also equal to y that you have here. And then the last but not the least, where you have two tangents that are drawn, right, and they are connected at this point, the distance from the point of meeting the circle to this point, right, they are exactly the same. The distance of here to here and this line, they are the same. Now let's try some examples to see how we can apply the theorems that we have discussed so far. In the diagram, O is the center of the circle, SQR, this angle is 60 degrees, and SPR, Y, is y, and SOR is 3x. SOR, that's 3x. So find the value of x plus y. So we have to find the value of y and x and then add it together. The first thing you want to do is y and 60. There is something common in these two. What, can you guess it? These are two angles within the same segment, so they are equal. Therefore, our y is going to be 60 degrees. Angle in same segment are equal. So angle in the same segment are equal. So that means here is 60. So if here is 60 and here is 60. Now, another thing is this. If these are two parallel lines, this line and this line, they are parallel. So if I extend this line upward, extend this downward, you will see that this angle and this angle, they are what? They are alternate angles. How are they alternate? These are two parallel lines. This angle and this angle are alternate. So if here is 60 degrees, here also is going to be 60 degrees. The same way here and here are alternate angles, 60 degrees as well. So if that is the case, the last thing we want to do, the question says we should find x plus y. So we need to know the value of x. How can we know the value of x? We need to find here. If we're able to find here, all right, you remember the sum of angle in this triangle is 180 degrees. So to find here, all right, let's label here z. To find our z plus 60 plus 60, z plus this 60 and 60 is 180 degrees. Sum of angle in triangle. Sum of angle in triangle. So our z is going to be 180 minus 60 plus 60 is 120. That is 60. So that means z is 60 degrees. So if this place is 60 degrees, all right? So let me replace it there, 60 degrees. Now this point to this point is angle on a straight line. This is a straight line. So this is angle on a straight line. And what's sum of angle in a straight line? 180 degrees. So I'm going to say 3x plus 60 is equals to 180 degrees. Angle on a straight line. Angle on a straight line. Sum of angle on a straight line. So that is 3x equals to 180 minus 60. That's going to be what? 3x is equals to 120. Divide both sides by 3. So my x is going to be equal to 40. So if x is equal to 40 and y is 60, and the question says find x plus y. So x plus y will be, x is what? 40 plus 60. And the total answer will be 100 degrees. So here is the answer to the question, 100 degrees. I hope that is clear. A circle of radius half centimeter, a chord 16 root 3 centimeter long is 10 centimeter from the center of the circle. Find correct to the nearest centimeters the value of r. So what we are going to do is to draw the circle, right? In a circle of radius, this, a chord. So we have to draw a chord as well. So there's a chord of 16 root 3 centimeter long. That's the length. 16 root 3 centimeter. That's the length of the chord. It's 10 centimeter from the center. This is the center. 10 centimeter from the center of the circle. You remember, according to the theorem, this line from the center of the circle to the chord, we divide the chord into two equal halves. That's number one. Then it forms angle 90 degrees with the chord. So we're asked to find, correct, to the nearest, the value of r, the radius, in a circle of radius r. So our radius is r. Our radius is the distance from the circle to any point of the circumference. So this is our radius. Instead of drawing it any other place, you connect it to this diagram. That is r, to give us a triangle. So here we have, if we put our angle here, this is the opposite, this is the hypotenuse, this is the adjacent. But since we are dealing with only half of the chord, so our adjacent is going to be what? It's going to be 16 root 3 divided by 2. Because we are divided by 2, our opposite is going to be 10 centimeters. We are looking for our radius, which is the hypotenuse, r. So we are going to use Pythagoras theorem, which states hypotenuse squared equals to opposite squared plus adjacent squared. So what is our hypotenuse squared? R squared is going equal to be 10 squared plus adjacent is 16 root 3 over 2. Okay, then squared. We're going to square it. So that's going to be r squared equals to 100 plus 2 is 16 is 8. So we have 8 root 3 squared. So r squared is going to be 100 plus 8 root 3 squared will be 8 squared is 64 multiplied by root 3 squared is root 9. And that's going to be r squared is equals to 100 plus 64 times root 9 is 3. So 64 times 3 is what? 64 times 3, 12, 18 is 192. So r squared is going to be 100 plus 192. R squared is going to be square root of, add it 292. And that's going to be, our r is going to be 17.088 or 17.08. All right? And we were asked to correct to the nearest centimeters. So to the nearest centimeter is going to be 17 centimeters. Do we have that in the option? Yes. That is the answer to the question. So we've answered this question. I hope this is very clear to you. If you have any question or if you have any of the theorems that you found valuable, you can go to the comment section and type the number of the theorem. And if this video has made sense to you, go to the comment section and type value, value, value. Remember to share this video with your friends. If you have not subscribed to this channel, do well to subscribe and like and comment. Thank you for being a part of this class. See you in the next class. Bye for now.